Hey everyone, welcome back to another Python tutorial. So guys, in today's video we are going to dive into the exciting world of graphics programming and create a rotating 3D cube visualization using Pygame. So guys, before proceeding further, as you guys maybe already know about the matrices, let me go through about the basics of these matrices. Please don't mind my writing here. It is 5 by the way. Here is a 3 rows and 2 column matrix, and if I'm going to multiply it with, we are starting from the basic matrix multiplication. So if I'm going to multiply it just with it has 2 rows and 1 column. Alright, so basically it is row and it is column. So these two must be equal if we want to multiply the matrices. These two entities must be equal. It is the rule of the matrix, as we already know maybe. So what if I'm going to multiply these two matrices, it will generate a matrix like 3 by 1. It means that 3 rows and 1 column. So if I'm going to basically it will be multiply by this, and by this. Alright, so if I'm going to multiply this, 1 multiplied by 1 is 1, and then plus, and then if I'm going to, the second part is 2, so 2 multiplied by 2 is 4, so I'm going to write here 4. Alright, and then 1 multiplied by 3 is 3, and then plus 2 multiplied by 4 is 8, and here again 1 multiplied by 3, well, it is 5, and plus it is 5 basically, and 2 multiplied by 6 is 12. Alright, so as we can see, the result is 5, 11, and we have 17. Alright guys, so basically it has generated a 3 by 1 matrix, which means that it has 1 column and 3 rows. Alright, so what is the link between the matrices and the rotation of a cube? So guys, suppose if I have a 3D plane which contains 3 axes, axis y, axis x, and axis z. So if I'm going to create a 3D cube here, so it will be like this. Alright, so guys, it has 8 vertices. Alright, don't mind my drawing. So basically it is the 3D cube in 3 dimensions. So each vertex has a value of x, y, and z. Alright, so but in our screen that if we are going to create a 3D cube projection in our 2D screen of Pygame window, so we have only 2 axes, the x-axis and the y-axis. So how can we go from this to this? So to project the 3D cube into 2 dimension, if we are going to project this directly into this 2D plane, it will be like this. Basically all the points are overlapped with each other. So to convert 3D cube into 2 dimension, we are going to use a matrix multiplication method called a projection matrix. So here 1 0 0 0 1 0 and 0 0 0. So guys, here it is a projection matrix. So if I'm going to multiply it with the x, y, and z coordinate. So we will be having a result like x, y, and we have 0, because z-axis, if we are going to apply the same rule as we have applied when we were just multiplying these two matrices, so this will be the result. So basically we have converted a 3-dimensional cube into 2-dimensional by using this projection matrix. I'm calling it P. Alright, so if I'm going to apply this projection matrix, so I can directly project the 3D cube into my 2-dimensional screen. To view the 3-dimensional cube, I need to use the rotation. I need to rotate the cube in order to see all the vertices of the cube in my 2D screen. I need to rotate the cube. So how does the rotation matrix work? Now for the rotation, we use the rotation matrices. I don't remember them now, but each axis, x-axis, y-axis, and z-axis each have their own rotation matrices, which consists sine and cosine functions. So we multiply it with the projection matrix, alright, and then we will get the result in 3 dimensions. Alright, so these are the rotation matrices. How can we project this 3D cube into our 2D screen? So guys, this is the projection matrix in 2 dimensions, and here are the rotation matrices. This is the for the z-axis, for x-axis and y-axis. These are the projection matrices. So let's start the code. So guys, we start by import Pygame library. So basically it imports the Pygame library, as we see, which is used for creating graphical application in Python, and then we are going to import math with asterisk. So guys, it imports all functions and constants from the math module. This allows us to use mathematical functions like cosine and sine without prefixing them with math. Alright, so and then I'm going to again and another thing I want to import is system module. So basically this system module I am importing is because I want to, when user is quitting the Pygame window, the script should stop working. Alright, so I will be using it. So guys, and then I'm going to define my window size. So I'm going to define that my window size should be 800. Alright, you can adjust this window size as per your requirement. So basically 800 means that it defines the window size of 800 multiplied by 800 pixels, and then I'm going to define my rotate speed. Alright guys, my rotate speed is 0.02. Basically it is the speed at which the cube will rotate. Now I'm going to create my window. So this window variable, I'm going to use this Pygame dot display dot set mode. Alright, and inside it I am going to assign it my window size, and again for the width is window size. Alright guys, so basically this line just creates a window of size of the defined window size using Pygame dot set mode method. This window will be used for rendering the graphics. And then guys, I am going to assign the clock. So I am going to use this Pygame first time, and then I need to use this clock method. So guys, basically creates a clock object using Pygame. this object will be used to control the frame rate of the application. Alright guys, now next thing I am going to assign the projection matrix. So we have already discussed what projection matrix is. I hope I don't need to go through it again. It is 1 0 0, and then we have 0 1 0, and at last we have 0 0 0. Alright, so here is our projection matrix. This matrix is initialized as an identity matrix, which means that it does not perform any transformation. Alright, so and then I'm going to assign the vertices, which are the cube points. So for this I'm using a for loop. For n in range, it will be running till 8. It initializes a list named cube points containing 8 elements. Now I am going to assign each vertices one by one. So there will be from 0 to 7 8 cube points. Here are the cube points. So guys, the following lines assign the coordinates of the vertices of a cube to the cube points list. Alright, so these cube points 0 to cube point 7 represent the vertices of a cube in 3D space. Each vertex is represented as a list containing its x, y and z coordinates. Alright guys, now I am going to create a function called multiply m. So guys, this function will be taking two arguments, a and b. So guys, basically this function will multiply two matrices. So first we need to define the rows and columns of each matrix. So for this I am going to use this a rows then a, and then we have a columns, which will be len b. Len is 0. Alright, now guys, for the same for the second matrix, we just need to define b rows is equals to len b, and then b columns is equals to len b0. Alright, so we have defined rows and columns for both matrices A and B, and after that we are going to use this product method. So we need to find the product of two matrices. So I am going to define this list for I in range B column. For the second matrix, I am going to again in range A rows. So guys, after defining this product, I am going to use this condition. As we discussed earlier, that if we want to multiply the matrix successfully, there is a condition that must satisfy, that the columns of first matrix and the rows of second matrix must be equal if we want to successfully multiply two matrices. So I am going to create a condition to check this. A columns must be equal to b rows. Alright, so if this condition will satisfy, then I am going to apply this for loop, which is an a rows. Alright, and as a in a rows, and then I am going to apply another for loop for rows, which is B column. Alright guys, for the rows of the second matrices, I need to apply another for loop for B rows. Alright guys, so these are the three nested for loops, and then we need to use the dot product formula. So I am using this product which is containing I and j is equals to, I need to plus is equals to the from I index and k multiply by B of k and j. So guys, basically it is the formula of the dot product, because we are going to find the dot product of these two matrices, and then I'm going to use this else condition, and if the condition that does not satisfy this criteria, that A column is equals to B rows, then I'm simply going to print that incompatible matrix size. I'm going to just say that it is incompatible. We have checked the condition of incompatible matrix size. After this, we will return product. We are going to return the product. Alright guys, so before moving forward, we are seeing that there is a red sign here. It means that there is a problem with the syntax. It is saying that yes, instead of this I need to use this from net import all the libraries. Right? Now I think yes, this red color is gone. It means that this syntax is correct. This whole function multiply underscore m computes the dot product of two matrices and returns the resulting matrix. Now I am going to create another function called connect points. Now this connect point function is going to take three arguments, I, j and points. This function will connect or draw a line between 2 points on the window. Alright, now I am going to write a line to connect 2 points. Pygame dot draw dot line, and it's a window, and then we have 255, 255 and 255. I will explain this, what this line is doing. Points, I have this I and 0. I and 1, and then we have let's cover them in tuple. Points, j and 0, and here we have again points j and 1. Basically this line draws a line on the Pygame window surface starting from the coordinates specified by this point I and 0 and ending at the coordinates specified by j with white color. So basically here we are representing this RGB method with white color. Alright, it is 255 means white color and 0 means it is black. Alright, so basically it is the starting point and it is the ending point. Alright, So these two coordinates will be serve as a starting point, and these two will be served as the ending point between the line, and the line will be in white color. We can say that this function draws a line between 2 points on the window. Now guys, I am going to define the scale, which is 100, scale factor for the cube size. Alright, and then I am going to use this angle x is equals to angle y is equals to angle z is equals to 0. So basically it initializes the rotation angles of the cube in x, y and z axis to 0. Alright, so basically initially these all angles will be 0, and then I'm going to start our main loop. So basically this is the main loop which is true, and all of the next part of the coding will be inside of this loop. So now I'm going to define my clock dot tick in 60 seconds in 60. So basically limits the frame rate of 60 frames per second. And after that we are going to use this window dot instead of this I can use this fill method, and then 0 dot 0 dot comma 0. It fills the windows which is black color. Now we are going to initialize the rotation matrices. Alright guys, so as we discussed in earlier at the start of the video, we have seen the rotation matrices of x-axis, y-axis and z-axis. So I am going to initialize them. So these are the rotation matrices. These matrices will be used to rotate the 3D cube points in each frame. Now I am going to define my points. So for points I am going to use this for loop. Instead of I am using this underscore in range the length of cube points. So guys, basically this initializes a list called points with the same length as the cube points list, with each element initially set to 0. Alright, then I is equals to 0. So I am going to run the loop for point in cube points. Alright, so basically this initiates a loop over each point in the cube points list, allowing each point to be transformed and projected onto our 2D screen. Alright, and inside this loop we are going to represent our rotated matrix with the calling function we have defined to multiply basically we are going to multiply our rotation matrix with the projection matrix. Alright, so to define that we are going to use this rotate x is equals to we are going to call this function, and it takes two arguments. I am going to say that the first one is rotation x and the second thing is point, which is in for loop, and I am going to rotate y, and the same function I am going to call, and in this time I am going to rotate y and rotate x. Alright, and at last at the variable rotate z I am going to use this multiply m function, and in this I am going to use the same method, that rotation z I accidentally rotation y, and I need to use here rotation x. After that rotation z I am going to use rotation y. So guys, basically these lines apply the rotation matrices to each point of the cube in succession, resulting in the rotation of the cube in 3D space. Alright, So after all of this, after storing their dot products, I am going to create a variable called point 2D, and in this variable I am going to again call this function, and inside this I am going to multiply the projection matrix with rotate z, which has the dot product of our third dimension. So basically this line multiplies the rotated 3D points by a projection matrix to project them onto a 2D plane, simulating a 3D to 2D projection. Alright, the x coordinate, so I am going to name it x is equals to our point 2D with index 0, multiply by our scale, and then I need to add the window size divided by 2. So guys, basically this calculates the x coordinate of the projected point on the screen, scaling it by a factor and adjusting the position based on the window size. Alright, so similarly I am going to do it for y. I am using this point 2D, but now I am using this I and 0, which is the second coordinate, and multiply it with the scale factor plus window size divided by 2. Let's do something that we should cover it with these brackets and remove the bracket from here. So similarly, x coordinate is calculate the y coordinate of the projection point on the screen. Now after that I am going to define this points list which I have defined earlier with xy coordinate. Okay, and then I am going to increment the I variable which I have initialized earlier with incremented with 1. So basically this update the points list with the projection 2D coordinate of each point. Alright, so basically it will be increases and it will be updated as the loop is running. Let's move forward. So I'm going to again use this Pygame. So basically to draw the circle, to draw the vertices, I'm using this draw dot circle method, and in this I'm going to initialize my window, the color, and then after the color we have the coordinates which is x and y, and then we have this number, and then I'm going to initialize 5. Guys, basically this draws a red circle representing a point at a projected 2D coordinate of each point on the Pygame window. Alright, now I am going to initialize the connect points. So there are 12 connected points, so I am just going to initialize them with this point. So I have initialized these points here, connected points. These lines call the connected points function which we have defined earlier to draw lines connecting specific points of the cube, creating a wireframe representation. Alright, so guys, let's move forward. So after that I am again going to create a loop in Pygame dot event get. Alright, basically if I want to exit from the Pygame window, so that is why I have created this for loop. So what it will do, it will see an event. If the event is triggered, I'm going to use this type equals to Pygame dot quit. Alright, so if the event type is that if the user cross the window of the Pygame, then the Pygame should be quit. Alright, so after that it will not quit. Basically we are going to write the code afterwards. So as we all know that the program will be run from top to bottom. Basically to avoid any problems, I am going to use the sys method. So I will just use sys dot exit. Alright, so basically after this event occurs, the Pygame will quit and the script will stop executing. So we also have this again we have another condition. So if the game does not quit, then I'm going to use this Pygame dot key dot get pressed. So basically get pressed method will check that which key is pressed. Basically this block handles Pygame events such as quitting the app and key presses for rotating the cube. Alright, now I am going to go through one by one that what are the settings that I have set in order for the cube to rotate. Alright, use this if keys Pygame dot k. Alright, so and then I'm going to use this R. So if the R key is pressed, then angle X is equals to angle Y is equals to angle Z is equals to 0. So basically this checks if R key is pressed. If it is pressed, then it resets all rotation angles to 0, effectively resetting the rotation of the cube. Alright, so similarly for this I'm going to use the same. Instead of R, I am going to use this A method, and in this A method I am going to use this angle Y, and I am going to increase the rotation of angle Y. Rotating speed is increased. So basically it will still check if the A key is pressed, then it will increase the rotation speed of the cube around Y axis. And similarly I am going to use keys Pygame and no, I don't want to run this, and this time it is D. Alright, as similarly as A key, if the D key is pressed, then the angle Y is decreased with rotation speed or rotate speed. Alright, so similarly it decreases the rotation speed of the cube around Y axis. So another keys Pygame, this time instead of D I am using this W. So basically I am going to use this angle. This time I am using this angle X, and I am going to increase its speed. So guys, it will check if W key is pressed, then it will increase the rotation speed of the cube around Y axis. And then similarly, if I am this Pygame, and this time I am using this S, and this S key will do is that it is going to decrease the speed around X axis. So again, if for Z axis I am going to do the same. So I am using the key Q, and then I am using this angle Z here, and this time I am going to decrease the speed, rotation speed if the Q key is pressed. Alright, so basically it decreases the rotation speed of the cube around the Z axis. And similarly, Pygame, and after Q I am using E variable. So if the E key is pressed, then it will increase the speed of Z axis. So guys, basically these all the lines allow the user to control the rotation of the 3D cube using keyboard keys like A, D, W, S, Q and E, and reset the rotation with the R key. Alright guys, so basically you can change and modify these keys as per your requirement. Let me see if yes, there is an issue, that is angle Y. Alright, now let's update this Pygame dot display dot update method. So basically it will this updates the Pygame window to show the changes made in the current frame, effectively rendering the updated frame to the screen. Alright, it is all displayed here. Let's run the program to see it in action. There is an error. Yes, it is in Y point that I have defined. Here it is. Yes, so instead of I should have used 1 here. So now let's again run this program. Yes guys, it was not displaying correctly because basically I need to instead of rotation X, I need to use here the rotate X, which I have already computed here, and then after this I need to use here rotate Y. Now again run this program. Now it is working fine. So as we can see, it is the position of the reset here. Alright, so as per our, let's check each condition that we have displayed here. Memory usage and everything is here. Yes, these are our conditions. So for the R it will reset, and for A it will increase the y-axis rotation. So let's check it. So guys, as I press A, the cube is rotating in y-axis, and it will increase the speed of the rotation speed as I press A. So I'm going to press D, then it will decrease the rotation speed in y-axis. So if I'm going to press W, then it will start moving in x-axis. Alright, then if I'm going to press S, then it will start moving in x-axis. Then it will increase the rotation speed. Then if I'm going to press Q, then it will move in z-axis. It will decrease the speed. And then if I'm going to press E, then it should increase the speed of rotation, and it will start moving in z-axis also. So if I'm going to adjust it according to me, I'm just playing with it. So yes, it is a whole cube. We can see all these vertices here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices of this cube, and I can just rotate it to see you that if I'm going to press E, it should rotate it, and it is basically I'm pressing E and it is rotating the cube in z-axis basically. We can see that. Alright, so basically in z-axis, the rotation z-axis, we can just see that how can we project the whole 3D cube into our 2D screen. Alright, this is how we can done this. So basically these dots we have already defined in red circles, basically which are being served as our vertices, and these lines we have represented in a white color in black screen. Alright. So guys, and there you have it, a simple yet powerful 3D cube visualization in Python using Pygame. I hope you found this tutorial helpful. Right. So if I'm going to close it, you can see that it is just generating a message. My current version of Python and Pygame version, and it is a default message from Pygame community. So let's close this resource monitor also. So guys, thank you for watching. I hope you found this tutorial helpful. Please do not forget to like, share and subscribe for more Python tutorials. Again, thanks for watching and happy coding. See you in the next video.